Okay, so for today's class, we'll be looking at adding algebraic fractions. So, what are algebraic fractions? Algebraic fractions are fractions that contain algebraic expressions like letters and numbers in the numerator, which is the top of the fraction, denominator, which is the bottom part of the fraction, or both. Instead of just numbers, they include variables. Now, this is an example of a normal fraction, what we will consider a normal fraction, right? So here, if we can see it properly, we should have, this is what? 3 over 5. So this is just an ordinary fraction. And what you realize about this fraction is that it has no letters. No letters are there at the top part of the fraction or the bottom part of the fraction. So if you look at the top part and the bottom part, there's no letters, meaning there's no variable. However, if we look at the examples of algebraic fractions right here, we'll realize that there are letters that are in the fractions. So for this example right here, you'll see that we have a variable at the top part of the fraction, whereas the second fraction, we have our variable at the bottom part of the fraction right here. And for the third fraction, you realize that there are fractions on both the top and the bottom part of the fraction. And for the fourth fraction right here, we have 2x over 3y. So we have the x right here and the y at the bottom. So we have variables or letters inside these fractions whenever we're looking at the algebraic fractions compared to the normal fractions. Now, when we look at the recap, and we're going to recap on adding fractions. So we're just recapping on adding fractions. There are a few pointers I have below right here, but the reason why we're recapping on adding fractions is because we're gonna apply pretty much almost the same principle, almost the same exact principle when we're dealing with adding algebraic fractions. So if you don't know how to add fractions, especially when the denominators are different, then you're gonna be in problem. But luckily we're here and we're just gonna start by recapping and doing a quick recap on adding fractions. So we have 1/4 plus 1/6, and we're adding these two fractions. When the denominators are not the same, I'm gonna repeat, when the denominators are not the same, we multiply each fraction by the denominator of the opposite fraction. Yes, I know for persons out there watching the video, they might say, okay, what about the LCM or the lowest common denominator? Fine, that's also correct. But we're looking at a quick and easy way to get the answer, a quick and easy way to get our common denominator for these problems. So just simply for this video, we're looking at multiplying each fraction by the denominator of the opposite fraction. So different method, and for other videos or future videos, I will show different methods. But for this particular video, this is what we're doing. We're going to multiply each fraction by the denominator of the opposite fraction. Okay, so let's do it. So for this fraction right here, 1/4, the opposite fraction, its denominator is 6. So what we'll do, we'll multiply right here each of the fraction, the first fraction, by 6. Anytime you multiply the bottom part of the fraction, ensure that you multiply the top part of the fraction as well. The reason why we multiply both the top and the bottom by the same number is because we have to balance out the fraction. So let's look at this right here where we have 1 over 6. So we'll multiply this second fraction right here by 4 because it is the denominator of the opposite fraction. And remember, both the top and bottom part of the fraction must be multiplied by the same number. So if you realize, if you're looking at it, you realize that the fraction, each fraction is being multiplied, both the top part and the bottom part, by the denominator of the opposite fraction. So let's look at it right now. So we have 1 times 6, and that will give you, I'm going to write it at the bottom right there, 6, and 6 times 4, 6 times 4 would be 24. Plus, we have 4 times 1, 4 times 1 is 4, and we have 4 times 6 again, and that will give you the same 24. Now in order to get the answer, once they have the same denominators, now we can actually just add the two numbers at the top. So we have our 6 plus 4 all over 24. So all over 24. And that will be equal to 10 over 24. And if we want, we can easily simplify this fraction right here by dividing both parts by 2. So if we divide both by 2, we can easily get a simplified fraction. So 2 divided by 10 will give us 5. Over 2 divided by 24 will give you 12. So 5 over 12. Please note, so we completed adding the fractions and we had 10. We got the answer to be 10 over 24. That is already correct, but if we wanted to, we could simplify. So if we simplify using 2, then we would end up getting 5 over 12. So this is pretty much how we add fractions. All we have to do is multiply each fraction by the opposite, the denominator of the opposite fraction. So we're going to apply the same concept to these questions. So we have 1, 2, 3 questions that we're going to be looking at for adding algebraic fractions. So we have the beginner question, we have the intermediate question, and we have the advanced question. So we'll be completing 3 of these questions so that persons who are struggling or unfamiliar with adding algebraic fractions, they can be able to do what they need to do or move or have a better understanding of what to do when they're adding algebraic fractions. So let's get into it. So the first question right here, it is the beginner level and it is the easiest level. So we have x plus 5 plus, we have x over 5 plus 2x over 5. Now if you realize right here, both fractions right here, they have the same denominator. So because they have the same denominator, because it's the same, all we will do is just work what is at the top. So we're gonna work at the top right here because both denominators are the same. So let's go. All we'll be doing right here is to just add our equal sign. We'll put our denominator down, which is common right here for both fractions, just 5. So we have our x plus 2x. So x plus 2x. And what you realize when you have these right here, we have our x plus 2x at the top right here. And because these are considered like terms, it's going to be equal to 3x over 5. Now some persons may be asking or wondering, what do you mean by like terms? Because I know persons might still be wondering, what do I mean when I say like terms? Now the reason why we have 3x right here, the reason why 3x is right here is because we add the like terms. Now like terms are terms that are similar or can be added or subtracted, so they have the same term. So let's go. I'm going to show you an example quickly of what like terms are, so you understand what I mean. So when we talk about like terms right here, we're talking about this. So if you have, for example, x plus x, these are not numbers, but they are the same letters. Because they're the same letters, they are called like terms. Meaning, you cannot add apple and carrot. You cannot add pineapple and apple. They are not the same thing. So if you buy from the supermarket or if you buy from a fruits vendor and you say you want an apple and a banana, you cannot say that you have two banana or two apples or two apple banana. There's no such thing as an apple banana. So you group the like terms, meaning group the things that are similar. Group the terms that are similar. So if you have x plus x, the letters are the same. So you would say you have two x's. Just as if, for example, x mean if x means apple, then you will say if you have an apple plus another apple, you'll have two apples. Let me show you what I mean. So if you have a, which would be an apple, plus a again, and let's say that the a represents an apple. If you go to someone and you know they give you an apple and plus they give you another apple, you won't say that you have an apple and an apple. You just say that you have two apples. So this is what I mean about like terms. They must have the same letter in order to be a like term. They must have the same letter in order to be a like term. So x plus 2x will be equal to 3x. So this is what we have as the final answer for this fraction right here. Same denominator, so put back the 5. And we have x plus 2x. They are like terms, so we have 3x. Moving on. So question 2 is our intermediate question, and what we realize about this question is that it has two different denominators. So when it has two different denominators, we're going to apply the same method or the same concept that we did when we were adding the fraction, the regular fraction, which is right here. So when the denominators are not the same, multiply each fraction by the denominator of the opposite fraction. We'll be doing the same thing right here. So let's do it. So what would be the denominator of the opposite fraction for right here? So we have 2x over 2, sorry, we have 2 over 2x. So this is the fraction that I'm looking at right now. What would be the denominator of the opposite fraction if I am looking at the fraction 2 over x? It would be what? 3, right? Because that 3 is the denominator of the fraction beside it. So we'll be multiplying both the bottom and the top by 3. Remember, always remember to ensure that we have equivalent fractions. In order to balance the fractions, we have to ensure that we multiply both the bottom and the top by the same number. Remember, multiply the bottom and the top by the same number. Now, right here, we're gonna multiply the fraction now, which would be x over 3. What we're gonna multiply this by? What is the denominator of the opposite fraction from x over 3? It will be what? X, right? X is the denominator for this fraction right here. So therefore, we'll multiply this fraction by x. We'll multiply both the bottom and the top by x. Whenever you're writing the x, try as much as possible in algebra to have the x written as joined in two c's together. So that's the reason why both the multiplication sign and the x should look different. Alright, so let's go on and continue. So now that we set this out as to what we're going to do, let's multiply each of these fractions, and I'm gonna put it below right here. So what is x times x? Well, x x times x is equal to x squared. It means that it should be raised to the power of 2. When something is raised to the power of 2, it means the same thing as the number or the base is multiplied by itself 1, 2 times. So x times x is equal to 2x. What about right here? X times 3. X times 3 is equal to 3x. So when we multiply a letter by a number, we just put the number and the letter together. So x times 3 is equal to 3x. So therefore, our first fraction right here is going to be, and let me just separate this because this is not going to be our fraction, but it's just the working out in order to get the first part, the first fraction. So this will be x squared over 3x, and this is the first fraction after we multiply the x times the x, which will give you x squared, and the x times 3, which will give you 3x. plus 2 times 3 is 6, and x times 3 will give you the same denominator, which would be 3x. So now that we have the denominators as the same exact term, which would be 3x, now we can add the fractions, the denominators, sorry, together. So the numbers are the terms at the top. Now we can add them together or put them together. In this case right here, because they are not like terms, we will just write the numerator as is. So I'm going to repeat, because the numerators are the numbers and or terms, sorry, I should say terms. So because the terms are not like terms in both fractions, we will just write the terms at the top of the fraction as is. So this right here is our answer. And remember, these are not like terms. So let's look at number 3. Question 3. And we have a very interesting question right here, because for each denominator, meaning for each term at the bottom of each of these fractions, they are 2 terms. So we have 2 terms as a denominator in both of these fractions. When we have fractions, or when we're adding fractions where we have 2 terms in both fractions, we are going to apply the same concept as before, meaning that we are going to, when the denominators are not the same, multiply each fraction by the denominator of the opposite fraction. So I'm going back to this question right here. If you look, these two denominators are not the same. They are not the same. And because they are not the same, we are going to apply that same method. We're going to multiply each of these fractions by the denominator of the opposite fraction. So let's look at this one for starters. We have 2 over x plus 1. What would be the denominator for the fraction opposite to this one right here? Now if you look at the fraction opposite to this one, it would be 3 over x minus 1. So therefore we would multiply both the top and bottom of this fraction, which should be the first one, by x minus 1. So both the top and bottom will multiply by the same exact term, x minus 1. And for the second fraction right here, we will multiply both the top and the bottom by the denominator of the opposite fraction, which will be x plus 1. So therefore we will multiply right here, so by x plus 1. And remember, whenever we multiply the top part of a fraction, multiply the bottom part by the same term, because that's the way that we can get equivalent fractions. For those who don't know what equivalent fractions are, the video is on the YouTube channel. You can watch it or check it out. Alright, so let's go. So x minus 1 multiplied by 2. Now, whenever we see two terms, 1, 2 terms being multiplied by a number or one term outside of the bracket, we distribute. Now, I'm going to repeat. Now, what separates a term to know that you have more than one term? Plus or minus sign. So the plus or minus sign separates to say that we have more than one term. Now if you look at this bracket right here, we have x minus 1. So the minus sign would be the sign to separate the two terms. So one term is x, the other term is 1. So there are two terms in this bracket right here. Whenever we have two terms inside a bracket and we have to multiply by a single term outside of the bracket, we're going to use the distributive property. So I'm going to write it right here. We're going to be using the distributive property. So we distribute. And I'm sure we guys should know how to distribute, right? So distributive property is something that we have been, or any math student have been looking at in the early stages of mathematics class. And when you talk about distributive property or the distributive law, all it means or what it entails is that you multiply the single term or the term outside of the bracket by each term inside the bracket. So in short, the 2 will multiply the first term right here, and the 2 will multiply the second term right here. So let's try this right now. So if 2 multiplies 1 and 2 multiplies x, let's try it. So we're gonna have 2 multiplied by, so 2 multiply, what's the first term inside the bracket? That's x. So 2 multiplied by x, and we're going to have our plus 2 multiplied by, so the reason why I put a plus sign right there, remember that the 2 right here is a positive number. So 2 multiplied by, we just have the negative 1. So 2 multiplied by negative 1. Alright, so 2 times x is equal to 2x. And 2 times negative 1 will be equal to negative 2. So let's separate them so you can see properly. So for this right here, we're gonna have our numerator as 2x minus 2. So let's write it right here. So 2x minus 2 all over. Now in order to get the denominator for this right here, we're gonna apply the same method, but because there's 1, 2 term, remember what separates a term? Plus or subtraction sign. So we have x plus 1, that's 1, 2 terms, multiplied by x minus 1, that's also 2 terms. So what we'll be doing in order to get our answer right here for the new denominator is to apply the method where we multiply using the same distributive method, and we distribute our x to each term, and then we'll distribute our 1 to each term. Okay, so let's do it. So let's distribute the x to each term first. Let me color code it, so remember the 1 will multiply each term differently. Okay, so let's do it now. So x multiplied by x would be x times x, and we're going to have x again multiplied by, so plus, because it's a positive x, so plus x times negative 1. And what would that be equal to? So let's do it. So x times x, I'm going to put it into a, so x times x will give you x squared, and x times negative 1 would give you negative x. Now we're gonna do the second part, which is the 1. So 1 times x, and we're still using the distributive law or distributive property in order to solve this. So let's go now. So 1 times each of the term that's multiplying right here, each of the term that's in the bracket, I should say. So 1 times x, let's write it out. So let's separate this first. So 1 times x plus 1 times negative 1 will be equal to, well, 1 times x is just x, that will give you x, plus 1 times negative 1 will give you negative 1. So in order to get the denominator right here, let's quickly just write down all the terms that we have right here. So the first term that we have was x squared. So let's write this down right here. What we're gonna do is that we're just gonna add all the like terms together. So we have x squared. So x squared, that's checked off. And then we have our minus x. And right here we have our x right here. When we multiply the 1 times x, so we have plus x plus negative 1. So we can just write negative 1. Now, in order to write this more effectively, we can simplify all of this right here. So we're just gonna group the like terms right here. So for our denominator right here, we'll just group the like terms. So we're gonna group the like terms. And if you realize right here, there's just one set of like terms that are there, and that's the negative x and the positive x. Now negative plus positive will cancel. So if you owe x and you pay x, you'll have nothing left. So we'll just end up with this fraction right here, which would be, for the first fraction, we will have x, sorry, we will have, let me put it a little bit higher. So we will have 2x minus 2 all over. Let's write it now. So we have our x squared, and because these will cancel, so negative plus the positive, so negative x plus positive x, these two will definitely cancel. So because they will cancel, we'll just be left with 2x minus 1. And this is our first fraction. Now we'll just add our second fraction right here. Now, just like the method before it over there, we can quickly just know that we can distribute. So 3 times the x and 3 times our 1. So 3 times x would be equal to 3x, and put it right here just so you can see it a little better. So let's write it. So if we have 3 times x, I'm literally just showing you the distributive method at this point. So 3 times x will give you, 3x right here, see right here, and plus 3 times negative, 3 times 1, sorry, so 3 times 1, 3 times 1 would give you, 3 times 1 will give you 3. So that's all over the same denominator. If we have negative x minus 1 times x plus 1, it will give us the same denominators right here. So we can just write the answer, since we know it is the same as this one right here. So that will be x squared minus 1. And since we have the same denominator, which is x squared minus 1, we can actually just put all the like terms together. So when I say put all the like terms together, we can just add them just like this. So first like term would be 2x. So 2x plus, because we're adding right here, so 2x plus 3x, that will give you 5x. And remember, these are like terms, so it means that you have 2x. So if x is apples, it means that you have 2 apples plus 3 apples. That will give you 5 apples, so 5x. And now we have another set of like terms actually, because right here we have just a regular number. So just a regular number, which is negative 2 plus 3. So this is a negative number plus a positive number. So in other words, this is saying that you owe, negative means what you owe. So negative means what you owe, the minus sign, the subtraction sign in front of the number means that it's a negative number. So negative is what you owe. So let's read it. So you owe 2, and positive or plus means what you pay. So you can look at it just like this is a good example. So you owe 2 and you pay 3. So if you owe 2 and pay 3, that means that you'll have what? You'll have 1 remaining. You'll have one thing that you own. And if you turn it the other way, it means that if you have 3 minus 2, you'll still leave 1. So whichever way works for you, that's fine. So if you owe 2 and you pay 3, you'll have 1 remaining. That's just another way you can look at it. So because you'll have 1 remaining, or you'll have 1 for yourself, it means that you will have plus 1. So negative 2 plus 3 will give you plus 1. So that's pretty much it. This is the answer right here. It's the answer right here. Let's mark it. So we have 5x plus 1 all over x squared minus 1. And remember, what we did right here, whenever we have two terms as the denominator, we use the distributive property. So if you still need some help on distributive property or distributive law, then you can check the videos on the channel for more. But these are, or this is a method of how you can add algebraic fractions.